Right, I left you in part one where I just set me ring up, my blank ring, ready to cut my cam on my cam ring for my Magneto. So I'm just getting my sensors back together. What I've done since I left you, I've put my boring tool in, and if you remember I'd set that up already with this ring to get my .630 radius. I'll just clarify that size because I might have made an error in my last video. It's .630 radius, which gives you a 1.260 diameter. That's for the clearance of the cam. I'll just show you on drawing. That's this diameter that we're going to cut to. There's the cam lobe. This is what we're cutting here. So that's all set now, ready to cut. I'll just go through a couple of things which I may have missed on my last video, which people might wonder what's that there. This little ring at the bottom here is just a spacer to allow my tool not to bottom out on my chuck. So that I've made a little ring about 1/4 inch thick, a bit less diameter than outside of this and a bit bigger diameter than inside, so my tool's got room to drop into without catching chuck. So that's what that is. There are another couple of other things I wanted to say before I start. I know I said this is my budget miller, and it is. And all I've done, as I explained to you, I've put a couple of verniers on one on my quill, one on my x-axis, and I'm using a clock on back because I ain't got round to putting a vernier on y-axis. So that's what I'll be using. Now, I did say you can make this with limited tooling, and you can really. You just want a cheap boring head, a couple of dial test indicators, a couple of verniers, and I'll just show you tooling that you need. It's all on here really. If you've got a micrometer, you'll need that. You need a clock to set your job up in milling machine. You need a internal gauge to do your bore sizes. A cutter just to cut your slot. That's a cutter to cut the V slot, and that's just a centre drill. That's one of my broken centre drills that's got 60 degrees to give me that 30-degree angle on my slot over here. And this chuck here has got an old tapping where I use for scribing a line across to get me 90-degree axis to mark it off while it's in the milling machine. Feeler gauges to set your boring bar up, and that's all you need really. So I'll just go back to the milling machine now. So where I'm up to then, I've put my tool in my boring head. As you seen in my last video, I've set the radius to 0.63. I've just got to now move over to get my first coordinate point on the drawing here, look. My spindle is now in the dead centre of this bore. I'm moving over to get this first coordinate point to machine this first radius. That's one of 4 radiuses. So I'll be moving to each coordinate point around the job like that. So to get my first coordinate on my budget miller, on y-axis, if you can see there, I've got a clock. I don't know if you can see dial on it, just a second. My light's shining. I'm going to move over now. Just a second. Yeah, I'm going to move over 96 thou. trying to get in focus with the clock. So I'm coming around, look now, 50 thou, 60, 70, 80, 90, 96 thou, if you can see that. Sorry, my light's shining in way. So that's my y-axis set. Now I've just got to come over on my x-axis. Now you're not going to see this on video, I don't think, because it's not a very clear display on vernier. But I'm going to go over 173 thou. Just a minute, let me get focused. I'm trying to read this through camera and I'm not having much success. That's 172. Right, sorry about that. I was trying to dial through camera and I wasn't having much success. Right, so we've got set now then at them coordinates. Lock table off. So now we're ready for machining that first diameter, radius should I say, not diameter. And all I'm doing, I'm moving down, I'm feeding in by hand on quill. So we're cutting on this side here. Right, so that's that cut finished. That's my first cut on that side. So I'll just explain to you. If you've got your cutter set to the right radius, you should now have a diameter where you've cut to the opposite side. Well, the finished diameter has got to be 1.655. You started off, if you can see this drawing, that's as finished diameter we've got to get to. We started off at 1.575, that was the size of the internal cam lobe. So we've got to take 80 thou off, that's on both sides, so 40 thou on each side. So if your tool's set correctly, you should have a reading now of 1.615, and I'll check that in a minute. Just another guide for you, the counterbore here that's in the ring, that counterbore is machined to that diameter anyway, so you've got a bit of a reference point there. So when you've done your cut, you should just be touching on that counterbore, and that'll give you an inkling that you've got your cutter set right. But just to double check everything, I'll just put bore gauge in, and I'm just using a cheap silver line bore gauge here. They're as good as anything. It's just a comparison gauge really. I should have a reading of 0.615 now if everything's set correctly. I don't know if you can see my micrometer there. Right, I'm a quarter thou undersize. I'm not bothered about a quarter thou. So that's that one set now. So what I'll do now, I'm going to move from this position. Let me get my drawing. I'm moving from this position where I've cut this radius. I'm going to take me gauges back to the centre. I'm leaving this 173 where it is on x-axis, and I'm going to go back to 0 on dial gauge on y-axis, then move minus 0.096 to this point. So I'll just do that. Back to 0, then we're going to move over 96 thou. Put lock on. So now we're ready for cutting this side now. This side here. My drawing. So that's complete. We're now positioned at that point to cut this radius here. So that's that side done. I'll just check dimension before I move on. Yeah, that's okay. So now we're gonna leave the y-axis alone. That's the one with my dial test indicator on at back. We'll leave that be. Now we're going to move over to this side on x-axis. So I've got to go over 173 to get me back to 0, and then another minus 173 to get me to my next position. Right, so I've just moved that over off camera because you can't see what I'm doing with that gauge anyway, and I can't hold it and do it at the same time. So we're ready for cutting this third side now. We've done 1, 2, we're on number 3. side 3 done. I'll just double check this size now. I'll just show it drawing again. So now we've done 2 sides, we should have a size with the clearances. I'm just looking for it on drawing. This 1655 now, we've done both sides now, so I'll just double check that. I said I'd got a cheap silver line bore gauge. I didn't mean cheap, I meant low budget. Just try to show you how you can do things on with low budget equipment rather than having to have bees knees or everything. So we're looking for 1.655. There you go. Quarter thou over. I'm not plus or minus a quarter thou. Right, so now I'll leave x-axis where it is and I move now over on my y-axis using my dial test indicator. So I'll go back to 0, then I'll go to minus 0.96 to cut this last side here. So I'll just set it off camera. Right, ready to cut the last side now. Or the 4th side. Right, that's that finished. Right, so remember we're looking for a size now, 1.655 across that diameter there, which we got on that last diameter there. So using my budget bore gauge, we're looking for 1655. Yeah, quarter thou over. So I'm happy with that. Right, just a second, then I'll just... Right, sorry, just had to think about that then. Where we're up to now then is, we've cut the 4 corners. I'll just get my diagram again and show you where we're up to. Show you where we're up to on diagram, right. We've cut these 4 radiuses, 2, 3, 4. Now, we've got it left now, this material in here, both sides, opposite each other. So instead of going over 173, and this 96, I'm going to set the gauges back to the centre line at spindle and move over this distance for radius, 0.1975. That's taking me onto this radius then I'll cut this side, and then I'll go over here, put it onto this radius and cut that side to cut that out. So I'll just set it off camera. Right, so I've now come over front centre 0.1975 to cut that little bit out in the middle on this side, and then we'll go over and do this side. I don't know if you can see that on camera. You can see the portion I'm taking out, it's that middle portion that we're left in with them two radiuses met. Right, that's it, that's that side out. Now I just want to clarify something here to you purists that's out there. I know obviously I've not got an exact radius here still, because there'll be still a fraction left at the edge of that cut there on both sides. Now that's why I've put it on my rotary table. So now I can go over a few degrees at a time, probably up to 10 to 12 degrees each side, and just nick that last out to them sides. Now I will do it, but to be fair, it's really not necessary, because this portion here up to where cam lobes start on both sides, it's just clearance. The heel of the points cam follower does not, well, it doesn't on my bike, it does not touch this portion. It's clear. So it don't really matter if I could have left that bit in, but I will take it out just to be pedantic, I think. So I'm just going to move my rotary table now from this angle, parallel with table. I'm just going to go over 10 degrees like that each side, just to nick that couple of thou out of both them edges there. So, and then I'll do the same with the other side. So I'll just do that off camera. I'm back. I said I'd do it off camera, but I thought I'd just show you what I'm doing. I've just moved over 10 degrees in an anti-clockwise rotation, and I'm just taking the slightest bit that it left in, probably a couple of thou, if that. So that's that side took out. So now I'm going to go back over minus 10 degrees. And take this other side out now. Don't know if you're able to see that on camera. Well, it's the slightest of cuts, just on one little edge of where that radius is. So that's the reason I put it on rotary table. Now you could do the whole job on rotary table if you wanted, providing that your rotary table rotates concentrically with spindlet machine. Yeah, I'd rather do things by coordinates. So I'll just take this rotary table back to 0. So that's it now. We're back to square one. Now I'm going to do this side now, exactly like I've done that side. Right, I've moved over 197.5 thou. I'm on this side now. I'll just take them little corners off now by moving rotary table 10 degrees either way. Right, that's all boring done now. I've got my cam lobes in position where they should be. So what I've got to do now, I'll just show you on drawing where we're up to. Here's my 2 cam lobes that I'm left with, one on each side, 180 degrees. All this has been machined out now. Up to there, and same on the other side. Now what I've got to do, I'm set at that angle at the moment, on this centre line here. This centre line. I've got to move over now 15 degrees, if you can see that. 15 degrees to get me into the centre of the slot that locates on the magneto for the advancing retard. So I'll do that in part 3 and also show you how I cut the let me just get me so in part 3 we'll go through how I set this up to cut this slot, which is pretty straightforward, and then I've got to take it out at chuck to cut this 60 degree slot where the advance and retard lever fits in. So thanks for watching on part 3.